Start with this question. This is the APGP combined series, such as you can see the numerators are in a arithmetic progression 1, 2, 3, 4, 5 with a common difference of 1. And you can also see that the denominators is 2, 4, 8, 16, 32 in a geometric progression. And we have to calculate, this series goes on and we have to calculate the sum. As you can see that the values goes on decreasing, that is the first term is 1 by 2, that is 0.5. It's again 2 by 4, that is again 0.5, and then 3 by 10, 4 by 16 is 0.25, and it goes on decreasing. So eventually it will come, it will not be negative, but it will be 0.00, something like that. So let's start this. There is a way to calculate this series, we'll see this. So let's assume that we need to calculate the sum of the series that has terms 1 by 2 plus 2 by 4 plus 3 by 8 plus 4 by 16 and plus 5 by 32, and this series goes on infinitely. So we know that the common ratio that is uh, in the denominator in the GP is 2. That is, we can calculate it by 4 divided by 2, that would give us 2, or 8 divided by 4, that would give us 2. So the common ratio is 2. The trick in these type of questions is you just need to multiply the terms by the common ratio, that is r. So let's multiply the series with the common ratio, that is r, and then we'll proceed. So s is equals to, just write the first term leaving the space of the first term and write it afterwards. 1 by 2 plus 2 by 4 plus 3 by 8 plus 4 by 16, and this series goes on. Now we'll multiply it by common ratio, that is r. So it's 2. So let's multiply it by 2 into 2 and into 2 into 2 into 2 and into 2. So let's see what do we get. This is 2s and this is 1. This would be 1 again. This would be 3 by 4, and this would be um, 4 by 8, and then this series continues. So if we just subtract this first equation from this equation, the second equation, we'll get some terms, and then eventually we can solve this and proceed. So 2s minus s is equals to, uh, from this term and this term, this would be 3 upon 4 minus 2 upon 4, then 4 upon 8 minus 3 upon 8, and then we'll have some terms and it will go on. We haven't written the starting terms yet. That was 1 plus 1, that was 2, and minus 1 by 2. So for this, let me erase the first equation. We don't need the first equation because we have calculated it. We have used it. So 2s minus s would give me s. 2 minus 1 by 2 would give me 3 by 2. And then from here the series starts. 3 minus 1, 3 minus 2, that is 1 by 4, plus 4 minus 3, that is 1 by 8, and you can see the next term which you will get would be 1 upon 16 and 1 upon 32, and then this series will continue. You can see now, you can see that this series form is a geometric progression in itself, which we can now calculate the sum. It is an infinite geometric series. So the main thing in these type of series was just multiply the series by common ratio, that it was 2 in this case, and just subtract the equation, and then you will arrive at a infinite geometric progression, and you can calculate easily. So we'll proceed with calculating it, and we'll just get the answer. So yes, so the sum would be 3 by 2 plus. Now what is the formula for infinity geometric series? That is a upon 1 minus r. So a is 1 upon 4 divided by 1 minus r. What is r? You can calculate r by 1 upon 8 divided by 1 upon 4. That would be 1 upon 8 into 4 upon 1. That would be 1 by 2. So 1 minus 1 by 2. This would be 3 by 2 plus 1 by 4 into 2 by 1, or we'll get 3 by 2 plus 1 by 2, or 3 plus 1 is 4 upon 2, or we get 2 as the answer. So the answer for this question is nothing but 2. So this was a video from my side on AP and GP series when combined, calculating the sum. Just remember, the trick is multiply the sum by common ratio and just subtract the equation, and you will arrive at a infinite geometric progression. If you like the video, just subscribe to the channel and let me know in the comment section.